Hi, welcome to Simple Stoichiometry. This is the easiest way you will ever see. It is one of a kind. Nobody else has this method, and I promise you, you will never go back to do it any other way. You will not find this in a textbook. We are going to be looking at simple stoichiometry. And this means that for simple stoic, it simply means that there's one data set that they give you. That's all. We're going to start it out very easy and give you an easy example. Once you catch on to this, you will just fly. How many moles of ammonia gas can be formed from 1.62 moles of hydrogen gas? You can pause at any time and take notes. Step 1, skip 3 lines and write the balanced equation. Simple enough. So you write the balanced equation, N2 plus 3H2 yields 2NH3. Now I want you to put a hat on it. That means a line right above it. I call it a hat. Simple to remember. Once you got the balanced equation, you're going to put a hat on it. And there it is. So step 2, put a hat on it. Now you're going to, on those lines that you skipped, write grams and moles. Moles should be resting on the brim. It's got to be resting on the brim of the hat. Grams is above it. So step 3, label moles and grams, and then now enter the data from the question. So 1.26 moles of hydrogen gas, let's write that in, and let's write what you're solving for. You are solving for X moles of ammonia, of NH3. So write that as X moles. Your work is nearly done. Here's the magician pulling a rabbit out of the hat, and we're going to do that too. Here's your equations. 1.62 moles of N2 over N2, X moles over NH3. You're going to write this as a ratio. 1.62 moles N2 over 1 mole of N2 equals, make sure that's an equal sign, X moles NH3 over 2 moles NH3. It is extremely important that you label this properly. Otherwise, you get lost because then you might have grams in there and this will not work with grams. So make sure that you label everything. What you're getting from the balanced equation, from the coefficient of this, is the number of moles. All right, we got the answer, 3.24 moles of NH3. You are done. That's the answer. Make sure you write this as ratios. This only works for mole-to-mole ratios. You must use the mole sitting on the brim of the hat, no grams. So step 4, solve all problems using moles. You must use moles, the magical, mystical mole. Now if you want, you can solve for hydrogen gas and make that Y moles. However big your equation is, Y moles, Z moles, just go to town. You can just set it up just like this, and you have your ratios. Now, the only thing is that in chemistry, we have no mole machine in the lab. We have a mass machine. So everything's in grams. How do we do it now? So let's do it. 8.76 grams hydrogen forms how many grams of water? Skip a couple of lines, write the balanced equation, put on the hat, write grams, and then moles underneath it. So the moles is resting on the brim. Enter your data in the appropriate area, 8.76 grams. And it wants us to solve for X grams, but we're not allowed to use grams. We have to only use this doing moles. So change those grams there to moles. Make the little arrow, 4.38 moles. Now change that X grams to X moles. Now you got it. Now set up your mole-to-mole ratio. 4.38 moles of H2 over 2 moles of H2, that's from the balanced equation, equal, not multiply, equals X moles H2O over 2 moles H2O. This is an easy one, but it's just an example. 4.38 moles of H2O. Go back to your equation there on the hat. Now you can enter that data in right above it, 4.38 moles. But they want the answer in grams, so the very last step, change from moles back to grams. And the final answer is 78.8 grams. Awesome. This is the easy way. Now, for the next one, we're going to look at limiting reactants.